And we are live.
Cool. Okay, welcome back to Foiling Week 2022. This is the Foiling Week Forum, and we are into the SuMoth session of the forums. We are really excited today. This is the culmination of a lot of work with this really important challenge to build a sustainable moth. Today we have Politecnico Milano and Rafale ATS, a legacy team that has done other projects with Foiling Week. I am one of your hosts, Chris Museler, and then we have Bruno Gentile, who's the founder of the SuMoth Challenge and really has brought on a lot of sponsors and a lot of energy. He kind of had his own challenge with Foiling Week a long time ago. I guess Rafale is your legacy team?
Yeah, exactly. I'm extremely proud of seeing all the students here coming to Foiling Week to compete at the SuMoth Challenge. We just threw them some rules and they came back with a full boat, fully foiling. So yeah, super happy to have you here, guys. And as we said before, we're gonna just have a little talk. We wanna get your inputs from the manufacturing, from the design, and that's what we're gonna talk about today.
Awesome. And before we get started and introduce the teams face to face, I just want to ask you the brief question is what kind of partnerships have these universities created in terms of learning about the material science, the engineering? It's not all been in-house for them, has it?
I don't know. I think we should ask them.
Okay, good. Yeah. Let's get started then.
Yeah. So we can start with Politecnico Milano. Ladies first.
Okay. So hello and thank you. I'm Maddalena Rossi. I'm one of the two team leaders of the Polyme sailing team, and she's Beatrice. And we're glad to be here, and we thank you for everything.
Great. So let's introduce Rafale.
Yeah, absolutely, guys.
Hi, everyone. I'm Noah. I'm the captain of Rafale ETS. And we're here today with Rafale 3, our first sustainable moth. And this is Donovan, our communications director. And we're super excited to be here.
Cool. So as Chris was mentioning, what kind of relationships have you developed for achieving your goal of building the SuMoth?
Okay, so I guess that first of all, the most important relationship we had to build was inside our university, because we had to create our space between the students and between the building of a university to find a place to stay and to build our boat. And with that, we have been helped by our professors. And in addition, we also looked for some other sponsors outside the university to help us with some manufacturing, with some materials, and some technical advices to build our boat. I think that's most of what we developed in order to create the Tati.
Do you think there's one partnership that kind of took, more influence on the program, meaning in terms of, figuring out some particular engineering problem or material?
That's a good one. I think that the most important one has been the one who provided us with a recycled material. So recycled fibers of basalt and carbon. I think they have been the most important for our project, for sure.
Very cool. And what about, I know for Rafale, I have some inputs from the underground, let's say, knowing a little bit the team from the inside out. Rafale is not just ETS. There's a combination of schools at the moment. So how did you deal with that so far?
Yeah, so we had the chance of partnering between ETS and Yale University, which are two engineering schools in Montreal, Canada. So doing that, we were able to draw upon the expertise in sailing, but also composites, design, manufacturing from both schools, which are developed in their own way. So combining those two strengths from the students and the faculty, we were able to develop a much more refined product that we're happy to present today.
Great.
Cool. And I had a question for you. Maybe we can bring everyone to speed about the different stages of the SuMoth challenge. So if you can break that down into the multiple parts of, when it started and what stages that the students had to go through to pass each building block of the SuMoth they have here.
Yeah, so the SuMoth challenge, it's basically divided in 3 stages. So the first one is stage 1, which is a pure design. All teams can participate and present a report that is due a month before the official SuMoth challenge competition.
And when was that for this particular challenge?
It's today.
Oh, it's today. No. I mean like the first stage, the design stage.
How
long ago was that?
Due, a month ago.
A month ago.
Yeah, more or
Okay,
less.
gotcha.
And then we have stage 2 and stage 3, which are sailing. Stage 2, the advantage is that they can sail on their own against the GPS. They can sail in their own waters and record the upwind and downwind speeds. And stage 3 is what we're starting today, this afternoon, on the waters of Lake Ardat, which is racing against each other. And I'm extremely looking forward to that because it's been a long road. I'm super happy. And yeah, I want to see this SuMoth all against each other.
Great. So I guess we're gonna talk more about that. We're gonna videotape that. You all have been collecting data on your boats. We'll start with Milano and move over. But can you tell me how the very first test went with the boat in the water? Did everything work?
Not exactly.
Maybe each one of you can answer your experience there.
Okay, the first time in the water for Teti, fortunately has been pretty quiet since there was no wind, and we tried the boat on the motorboat. It was good because it showed us that the foil was making the boat fly, at least the main foil, while the rudder foil had still some problem with tilting angle. But now I think we fixed it. And it was very emotional, I guess. I mean, after an entire year of work, finally you can see your boat in the water. It's very, very nice. And we had some problem with the sail, but then also we managed to fix the rigging. And for the first time, that was it.
Cool. How about Rafael? Your first flights?
Yeah, so we pushed really hard to finish the boat on time and get at least a couple water sessions in before shipping the boat over here. So doing that, we were able to put the boat in the water, get it to fly. Unfortunately, due to flat water conditions, we were just pulling it with a motorboat. But overall, we learned a great deal from that, and we owe a lot of our preparation today to those tests that we did. But yeah, so still have yet to see it fly under sail.
Perfect. So there's a question I have, but I know more or less the answer. All teams have female sailors, and why is that? And how do you develop the relationship with your sailors?
I would say because usually they are less heavy. No?
I agree to some degree, but also simply in our case, there are not many sailors in our area who have experience with foiling small boats, and so it just happened that both sailors that we had are female. But also it is a nice bonus to have an earlier takeoff.
I agree, of course. I mean, our skipper, of course, is a WASP sailor, so that's why actually she's sailing Teti.
Now, question I had for your studies. You're all students, And, you know, there's multidiscipline. We have communications, we have engineering, we have a lot of design components. And the question I have for you is, how much has this project kind of taken over your studies? Is it, and you can go each person, is it 100%? Because you have a bigger team. So maybe say how big your team is, and then how much of a percentage of your studies has been devoted to the SuMoth challenge?
I think that our studies are the basis for the design of our boat, but speaking of Milano, we don't have any faculty of nautical or marine engineering, so we tried to manage what we learn for different disciplines and apply that to nautical sector that is, I mean, same, similar, but not the same. So we have some troubles to adapt what we have studied on book on a real project on another sector. Also quite tricky.
Awesome. And is it your full studies right now, the SuMoth challenge, or do you have other studies?
Oh, of course, it's not our full study. I mean, we're doing university courses and exams, and on the free time we work on the moth. So for sure, it has been a big deal to organize our time this year, but I think it was worth it.
And same question for Rafael.
Yeah, so at the moment, everyone on the team is doing it on a voluntary basis. We all have courses to take, master's thesis, right, for some. And so it's really just the passion for the project itself that drives people to take extra time out of their day to come out and get their hands dirty at the workshop.
Yeah, actually, what makes me super happy about this, that the teams, is that many of the team members are actually alumni who are taking time off, like Donovan. He has a job. He finished school, and he's taking vacation to come and follow up with the team, even though he's done. And there's a similar situation with Torino and same with Southampton, that are all finishing school, and they finish with the cherry on the Sunday. I would say that's a really Quebecois way of saying it, like with the SuMoth, competing at the SuMoth challenge and putting the ground flat for the next team.
No, so maybe you can explain to us that how these teams roll, because a project can last 2 years. And so how does the team manage, like yourself, finishing school but still being a part of it? Do you ask people to carry on, and how do you have continuity?
Well, actually, I went in the Rafael team in last September. When I arrived and started to create a new communication team, we were 5 in the club, and now we are 22, because we tried to create a new movement for the team. And then when I graduated in December, and I'm mechanical engineering, specialized in aeronautical design and structure and composites. So I tried to explain that I would like to continue the adventure with Rafael to my boss, and he agreed. And they would like to be a sponsor. So now we have Acodis as sponsor too, and we start to create the same dynamic in France around all the sponsors. So that's how I found the solution to continue to work on the boat, because it's now part of the project of my company. So yeah, it's like only on free time, but I'm an engineer, so I don't have free time. But it's like maybe 80 hours per week of work and of other work.
Yeah, serious commitment.
Yeah, that's awesome that you can get together with companies. I think all teams they start building up a relationship with the companies for sponsoring, and it's a great pathway for their professional career. That's how I managed to get into my professional career. Actually, was through a students' competition. That was founding member of Rafael one.
And a technical question, going back to the technical, and we'll get away from the 30,000 foot and come back down again. All the different parts. That's what's so awesome about sailing. There are all these different components that you have to reach into all these different areas of expertise, areas of study, even all the way down to the communication side of things, which we're really close to here at Foiling Week. So in the technical parts of the moth, the structure, the materials, the design, and then the application of the running systems, the load testing, could you kind of, each one of the teams, can you pick the one that was the biggest challenge? Meaning, it might just be the material that you decided to use for the hull, but was there one area that you went on a path and you really had to kind of stop and reevaluate, the biggest challenge in the whole moth project? Was there one area? Maybe we'll give Rafael,
Yeah.
and then we're going to come back to you, okay?
Yes.
Well, Chris, you gave it away. It's the materials for the hull.
For you.
Yeah.
Yeah.
We used a resin that is still quite rare in industry. It has the unique property of being recyclable, but also processable at room temperature. So without requiring an oven or large equipment.
So chemical.
Yeah.
Yeah. It's
So the challenge with that resin, since it's a relatively new product, is that we didn't have the knowledge in our circle of expertise to make large parts with it. So our supplier was doing lab scale tests and was like, yeah, it looks great. Here it is. And we make our first part and it never came out of the mold. So
it basically didn't cure, maybe, or
no, it cured, but it cured so well that it stuck to the mold.
Mold release.
Yeah. So that was the releasing challenge was the first of many to overcome in order to make nice parts with this resin.
And there's a huge amount of value in terms of using resins like that compared to traditional resins for a lot of obvious reasons. Can you tell us the type of resin that it is without throwing it under the bus?
Yeah. So most resins which are used in the nautical industry right now are called thermoset resins. So they cure, and once they cure, they are permanent. So there's no way of remelting them to make different parts. You can only burn them. So this resin we were using is a thermoplastic resin, and so it can be reformed, it can be dissolved, it can be separated from the fibers to make totally different parts, but it can also be chopped up and reprocessed with the fibers to make other types of parts, whether they be nautical or otherwise.
Awesome. Now, back to Milano.
Yes. Okay.
I suppose that for us the main problem was the material for the mold of the hull, because we use this material that is lebanite, that comes from the pyrolysis of glass fibers, and it's a secondary raw material, and we studied it a lot, and we have some troubles to follow the geometry that we have designed previously with this material that doesn't work exactly how we expect.
And this is creating the mold.
Yes.
Right.
Mold.
Okay.
So the mold is 100% recycled and recyclable, but this gives us a lot of troubles in the realization of it.
Okay, well, that brings me up a question for Bruno. We're just talking about the tooling. Do you use that term? The tooling, which is the equipment that is basically the molds that you make these products that your resin stuck to. So that's pretty far down the rabbit hole of how far you go in terms of being really true to this whole project, like a life cycle assessment, the materials that you use. Would you say that's pretty extreme in the marine industry to use recyclable materials, not just for the hull and some components, but go all the way through to the tooling and maybe other ancillary parts of a build project?
Yeah, I think that's the bottom line of the whole problem, because we build boats that are 20 kilos, like a moth, a hull, but the mold weighs 100 to 100.
Yeah.
So we are just making look like we're saving a material on the moth, but actually we're making a lot of trash. That's the composites industry. I'm an aerospace engineer in composites, so that's kind of my job. And I know the problem from the inside. And what these guys have been doing, I'm not gonna throw it away. We will see it on stage 1 at 12 today. So they all came up with quite interesting solutions, like the Madalena and Beatrice were telling about Lebanon. That's a material they developed at Politecnico di Modena, the Milano, and they're using for building the SuMoth. Rafael had a different approach by making their mold smaller and also recyclable in a different way by sponsors. So they all came up with different propositions and solutions, which are all great. And all we want is for these solutions to come up and that are broadly used in the industry, because it's nice for the SuMoth. We're saving some of CO2 emissions, but it's not enough. We need to do much more.
And on that question of impact, and maybe Donovan, you're a communications person, in your heart probably too. Do you have any thoughts that it's impressive to see what these teams are accomplishing, but it's almost like you can't yell loud enough about this to get the word out to the industries that are trying, but they have a machine rolling that's creating product and has a lot of waste in terms of production. From a communication side of things, do you or the school or just in your personal thoughts have some urge to spread this word through industry?
Yeah, we find some solution for that, because we try to organize our communication team around one object, is that for Rafael, but for innovation in general, to spread it to Europe and of course Canada and US. But many sales team and engineering company are already in France, or already in field. The field are already developed, so we just need to get direct contact, and it's like in every sport. So just have a common aim, and you just go through it. So the way is really simple. We just have to show that we have already answer and capacity for company that costs maybe a little less, and that's the first and the basic for them. It's really easy to communicate with them. When you say we are cheaper, that's it. Yeah, they're ready for text with us.
That's how you get their attention.
There needs to be a financial point, otherwise it's really hard to convince the industry about it. So we need to find good solutions, sustainable and also economically viable.
Cool. Any more questions, Bruno?
I think I have one question for each. Let's start with Rafael. Why should Rafael win stage 1 this afternoon?
The product we've developed, I think really pushes the boundaries of what you can build, what you can build a boat out of. So again, using this resin, which I spoke of previously, but also using techniques which don't require molds at all, such as machining of raw materials directly to make parts, using additive manufacturing, again, to avoid the use of tooling, and overall using these new technologies to minimize the amount of material used, and overall have a product that can still perform, but at a lesser material cost.
Thank you. What about Milano?
I think we could win stage 1 of a competition because we really found out some, I think, amazing solutions to face the problem of the environment impact we have with our technologies and materials. And I think Glebanite is for sure our key point. And moreover, we also put a great effort in recycling and reusing parts of our boats coming from other boats already used and not capable of going in the water anymore. So this is for sure one of our point, and a lot of other parts of our boat are made of. Are made of other part adjusted and made suitable for our boat.
It's also obstacle.
Yeah,
Like you
exactly.
modify 16 parts to fit the SuMoth.
Exactly, upside.
And Bruno, I guess my last thought with you and with everyone else is that it seems to me that particularly with this challenge, yes, we want these boats to fly. Yes, we want them to be fast and fit within those parameters. But it's not just that you're measuring here, right? Like in terms of, one team may have a higher, better solution for environmental impact,
Yes.
a higher percentage of recyclables or other solutions, but the boat may not fly as high or as fast. Right? So I think when we look at this project and we look at this stage of the project, which is really exciting, I know you got very excited. We have to frame that in the bigger picture, right?
Yeah, absolutely. Like that's why we have these 3 stages. So you need to combine all these different problematics. So you need to be sustainable, have a nice design, and be efficient.
Cool.
Like without that, we won't be able to convince anyone. We need to have all these problems, let's say, solved before we can convince the industry to apply the technologies that they are developing through the SuMoth challenge.
Yeah, it seems to me that other vehicles are a little bit easier to gain success, like bikes and motor boats or whatever, things that just sit stable. But this is so much more dynamic. So it's really fantastic that you all have taken on the challenge. I know it's spanned some various students, and the teams grow and shrink. But congratulations for this stage, and we can't wait to see you at noon.
Thank you.
Thank you so much. Thank you very much for joining, guys.
Thanks for joining the forum, and we will be back with the next group.
Yes. Thanks, Riz.
Thanks, Bruno. Ciao.